Um, my name is Michael Lennon, and I work as an inspector across various SEAI schemes. I suppose we can use this webinar as a good opportunity to share some of my learnings during inspections. As I said, we're going to look at the different specifications for roof insulation grantee as it works under the programme. So as Ronan said, if you have any questions during my presentation, feel free to just pop them into the Q&A section there, and any questions we'll hopefully get to at the end of the session. So we're going to look at the agenda first and foremost. And as part of the agenda, we'll be covering some of the areas to do with the roof insulation and ventilation requirements. So we're going to look at the standards and requirements and for ventilation. And the Better Energy Homes team recently have issued a technical bulletin, whether it was last year, on this topic. So it might actually be a good idea or a good time to revisit some of these areas. We're going to look at meeting a whole house solution in relation to roof installs, pipe insulation standards, handling of electrical items, insulation on the water storage tank, and then we'll refer back to maybe the supports for contractors as well as the Q&A section at the end. So the first topic we're going to look at is the roof ventilation standards and requirements. And because the quality of service delivery is central to the reputation of the grant-funded works, it's always good for the contractors to make themselves familiar with some of the key SEAI documents. And so the first one we'll look towards is the technical standards and specifications. And so we'll be looking towards this throughout the presentation, specifically section 6.4 and 6.5. And this document is a good reference for contractors carrying out works under the programs. There's also the code of practice document, which contractors must adhere to when carrying out works under the program. There's also the quality assurance and disciplinary procedures. And again, this is going to be for contractors to focus on competence and compliance under the scheme. And again, this document is something that we look towards for the roof insulation upgrades. And in relation to this document, I would definitely urge contractors to download it. Just you can see the QR code there. It's something that I would suggest that you do download. If the contractor would imagine that they were an inspector themselves, at the back of the document there is Appendix 2, and I would encourage you to have this, have members of your QA team inspect their own work prior to signing off on the declaration of works. It has all the checklists that the inspectors will go through during an inspection, and it may prevent you from a revisit or rework on the home. So it's definitely something that I would suggest that contractors would download and have available to check prior to signing off. So we're going to look at the different standards, and the main document, I suppose, is the technical guidance document part F, which deals with ventilation. Sets out the different guidance, the different ventilation types in buildings. It just means that there's proper ventilation provided, especially in roofs. And there is a section 2 that highlights specifically condensation in roofs. So we're going to look towards that throughout the presentation. We also have this SR54 code of practice for the energy efficient retrofit of dwellings. And again, this is important for contractors to gain a good understanding of this document. It includes all guidance to do with all retrofit upgrades, including roof insulation and ventilation, to meet the standards. And again, we are going to look towards section 6.3, which deals with insulation and ventilation. So, to do with roofs and attics in particular, not all attics may require roof ventilation. But with the installation of high quality insulation, the ventilation of roof spaces may be necessary to remove water vapor and prevent condensation in attics. So again, we look towards this SR54 document, and specifically there's a section in it in Appendix I, Table I.1 here, which deals with or provides a moisture risk survey. And this is something that I would urge contractors to have a look at as well. There is this survey that you would do initially when you're looking at the installation for roofs. It does say that not all roofs require ventilation, and as an installer, you would have to assess the roofs, whether ventilation is required or not, and if it is, how much ventilation. So if there's no evidence of moisture related problems in the roof, and there's at least 100 millimeters of existing insulation, then insulation levels may be topped up without the need of additional eaves ventilation. So that's really important. And we're going to look at some scenarios and some things to watch out for. So if you're looking at a roof on your install, you're keeping an eye out for rotting or damage to the roof timbers. So when you're doing your initial survey of what's needed, you're looking out for signs of rotting, signs of wet mold on the roof timbers, signs of moisture related problems. So there could be condensation dripping on the insulation and wet insulation, etc. Or there could be just visible signs of condensation throughout the roof. So if you're coming across situations where a roof is already showing signs of condensation, then roof ventilation will be required alongside the insulation top-up. So we have examples to look at here. And this particular example has an attic here with existing insulation of around 200 millimeters. So, okay, you'll do your assessment. You'll be able to top up insulation levels. But because we're looking at an attic here with existing moisture issues, just condensation issues there on the underlay, your top up will be done, but roof ventilation will be a requirement, and that roof ventilation will provide good ventilation into the roof space. It will also avoid creating pockets of stagnant air. So it's something that would be required alongside your attic top up because you're seeing issues with condensation. We have another scenario here where you're in an attic, but there's very little or no insulation. So alongside your additional top up, new attic insulation would be required because there may be condensation issues. Again, alongside your attic top up, you'll provide your ventilation. And again, that will hopefully eliminate any pockets of stagnant air, provide gentle air movement through the attic, and good cross ventilation. So we look at low level ventilation, in particular on a pitched roof. So in general, for a pitched roof, ventilation is installed at low level, at eaves level, and the standards call for a continuous gap of 10 millimeters or equivalent on the longest side of the roof in order to get that cross ventilation. So if you have if you have a soffit that's suitable, you might be able to use or install soffit vents. If the soffit is unsuitable, you might be able to install roof tile vents or slate vents. It would be necessary to install high-level ventilation in some scenarios. So you're looking at situations where the roof itself requires low-level ventilation, but the pitch of the roof is greater or exceeding 35 degrees of the pitch. That would trigger the necessity to install high-level ventilation alongside your low-level ventilation. So if the pitch is greater than 35 degrees, or if the span of the roof from wall plate to wall plate is greater than 10 meters, that would trigger high-level ventilation to be installed alongside low-level ventilation. And high-level ventilation is half the amount of low-level ventilation. So that's 5 millimeter wide strip or equivalent running the length of the ridge. So again, low-level ventilation is 10 millimeter continuous strip or equivalent. High-level ventilation is half that, 5 millimeters. We look at situations of different roof types, potentially where you might have a lean-to roof pushing up against the wall, or you might have a monopitch or single pitch roof. Again, this should have ventilation openings at low level and high level in order to achieve that cross ventilation into the lean-to roof. And again, the ventilation at high level may be arranged through the roof covering. So again, roof tile vents if it's high level, because there's no soffit on that section. Again, low level is going to be a continuous strip or equivalent of 10 millimeters running the length of the soffit. And again, high level, 5 millimeter continuous strip along the length of the ridge. So we look at an example of a standard rectangular roof here. And if roof ventilation was required, then you're probably thinking how much ventilation or how do we calculate it? So we take an easy example here. If we have a 7-meter long soffit, roof ventilation is going to be calculated in millimeters. So the first thing we do is convert 7 meters into 7,000 millimeters. We look at the length of the soffit. So we have a straightforward rectangular roof here, 7 meters to the rear, 7 meters to the front, which equates to 14,000 millimeters in length of soffit. And that there figure is multiplied by the 10 millimeters strip that we were looking for, the continuous 10 millimeter strip. So it equates to 140,000 millimeters squared of a ventilation requirement for that particular attic. And again, this is where you would choose to install soffit vents if you had a suitable soffit, or roof tile vents, just depending on availability and soffit. And just double check what capacity your vents are, and you can then do your calculations to see exactly how much vents you need to install. So just check I suppose, the roof tile vents or the soffit vents that you're using, and what capacity each vent has in relation to free air moving through it. We look, and throughout this presentation, we look at some good examples and some poor workmanship as well. So this is something that you'd be looking out for, and especially an inspector as well at the end of the work would be looking out for. So we have a situation potentially where a roof install has been completed, signed off. As an inspector, the inspector will be checking to make sure that there's no signs of condensation, dampness, or blocked ventilation. This particular image that we're looking at here has the insulation pushed too close to the soffit, plus the eave ventilation is blocked. And again, you can even see signs of condensation on the joist there, on the rafters. And that then would cause further issues in the house. This particular image on the right, you can see saturation of the insulation transferring through the plasterboard. And again, that's going to cause issues to the health of the building, the health of the occupants within the building as well. So these are things that we're trying to avoid by installing correct ventilation and by making sure that the ventilation is maintained, preventing these issues. We also have example where if blown fiber was used, we might have a situation where it looks fine upon install, but if the eaves were clear during install, it may have been blown closed at the time of inspection. And again, the good ventilation that was there might not be maintained properly. So we would suggest that you install ventilation cards at eaves level if that product's being used. If you're using blown fiber, it would be a requirement to install ventilation cards. And again, that's going to maintain the ventilation, preventing any problems further down the line. We also have situations where there's going to be extractor fans in wet rooms in the rooms below the attics. So again, there may be poor quality before you arrive on site. It definitely would be something that I would suggest that you need to discuss with the homeowner as part of your initial homeowner discussions. You will have to explain to the homeowner that there will be potential issues to do with condensation in the roof space if those roof or mechanical extract vents were not ducted. So again, as an inspector, this is something that I'd be looking out for. I'd be doing my initial inspection, looking at the different ventilation installed, whether it be existing or installed new on the scheme as part of the grant. And I'd be making sure that all extractor fans are piped to the eaves or through a roof tile vent, which we'll look at now in a second. So it's something to watch out for as part of your initial discussions. This is where there's good workmanship and what exactly we'd be looking to see on an inspection. So on the left image, we see a mechanical extract vent ducting being ducted out properly through the soffit, terminated with a vent that has the same diameter as the ducting itself. So we're not using existing soffit vents. We're actually purpose provided ducting on the extractor fan there. And then if there happens to be a soffit that isn't suitable, then we'd be looking towards using a roof tile vent. Because if you are using a roof tile vent to duct out the mechanical extract vents, we'd make sure that the ducting itself has no severe bends and that the ducting itself is insulated and ducted out through a roof tile vent if necessary. We also have situations where, due to the installation of external wall insulation, you might actually have a situation where the external wall insulation might block the existing ventilation. So on your initial assessment that the ventilation in the soffit might be appropriate. If you're doing an external wall insulation install at the same time, it definitely would be something to watch out for. It is something that is hard to see just on that particular picture, but there is existing soffit vents which are partially blocked or compromised by the external wall insulation. So it definitely is something to bear in mind when you're doing an external wall insulation job as well. Just to make sure that there is um, additional ventilation installed if you're blocking or compromising the existing soffit ventilation in the roof. And then this is the same example where the ventilation has been compromised completely, thus removing the roof ventilation and potentially causing further issues down the line when it comes to condensation or problems within the roof. So again, something to watch out for, something to talk to the homeowner potentially that you need. Another thing that we'd see from time to time during our inspections would be soffit vents that look visible, look to be working, but when you pay extra attention to what's going on, there actually is old timber soffit in behind that PVC soffit. So again, something to watch out for if you are installing insulation. If there's not correct ventilation there in the first place, and potentially very little or no insulation in the attic, you can't assume that the existing ventilation is working. It's something that you potentially would need to investigate as part of your work as well before signing off. So we're going to move on to the next section, which is meeting a whole house solution. And again, as part of your work, the contractor must ensure that in case of roof insulation, that an optimal whole house surface solution is provided where physically and economically feasible. So when you're arriving on site, you need to plan for the job, identify all the roofs throughout the building that are losing heat, what insulation materials are you going to be using, any possible or potential obstructions that may cause problems. And so again, we're looking towards achieving a whole house solution to each roof within the home. But we might have situations where there is extension roofs, flat roofs, room and roofs. These are all potential habitable areas of the house, heated, part of the thermal envelope. So we have two examples here that would illustrate this, and we have a situation where the attics themselves may be getting insulated, where we have an example of an extension, and the extensions have flat roofs. So as you can see here, the areas highlighted in orange would be required in order to meet the SEAI standard and to achieve that whole house solution and get your grant compliance. So we're looking at doing the whole house solution, including areas that have difficult access, like that. So we look at each type of insulation here. And this particular one is a pitched roof with insulation at ceiling level. These are relatively straightforward, practical, and low cost to treat. Again, it will be up to yourself what type of material that's used to achieve compliance. If ventilation is required, so if there's condensation issues or if there's less than 100 millimeters of insulation existing, you may need to look at ventilating that roof alongside your insulation top up. And then that calls for the 10 millimeter continuous strip at soffit level for a pitched roof. And again, the standards would highlight that the insulation at ceiling level would have or would be required to meet the standards of 0.16 of a U value. So again, that's something that will be needed to achieve compliance. If we look at potentially where you have an attic conversion or room and roof situation, we have a situation where we want to provide insulation at the point of heat loss. So again, whatever material that's used, whether it be fiber, foam, or rigid insulation, that can be used, but the ventilation requirements have changed where the insulation is at rafter level. And so between SR 54 and Part F, building regulations, that would call for a 25 millimeter continuous ventilation strip at low level. It would also call for a 5 millimeter continuous strip at high level, or ridge level. And it also calls for a 50 millimeter wide gap behind the insulation at rafter level. So different insulation at rafter level needs 2.5 times more ventilation at low level than it does on the standard pitch roof. Again, there's that 50 millimeter gap required in behind the insulation on the slopes. The target U value is 0.2, where insulation has been applied at rafter level. So again, we're looking at that exact example there where we may have a room and roof. And this particular example has a flat roof extension. So we're looking to treat all the heat loss roofs in the home. We have a room and roof scenario where there's habitable heated rooms up in the living space in the attic. There's also a flat roof that has habitable rooms. So again, it's the areas highlighted in orange there that are required to achieve that whole house solution. So as an inspector, we're coming along doing the same survey. We're looking at the heat loss roofs to make sure that it's getting that whole house solution and being achieved. So again, we look towards where we have a dormer room and roof scenario. Again, these might be a little bit more technically challenging to retrofit based on restricted access, etc. But we have a combination of different insulation methods. So we might have warm roof insulation along the rafters here. We might have ceiling level insulation up top or down underneath the voids here. We also have wall insulation on the vertical walls. So it's a combination of different insulation methods. And so SR54 would call for 25 millimeter continuous ventilation strip required at low level, a 5 millimeter continuous strip at high level, and again that 50 millimeter gap in behind the insulation on the sloping sections of that roof. So the vertical walls are treated the same as the rafters, and so the target U values be 0.2 for the rafters and vertical walls, and 0.16 for the insulation at ceiling level, which is the upper attic and the two lower void attics. We look at flat roofs now, and again, you might have a flat roof or a pitched roof less than 15 degrees for pitch, or really low pitched roof would be treated like a flat roof, which is defined in Part F of the building regulations. So we're looking at roofs that have restricted access, can be at times technically challenging to retrofit. The first time you'd retrofit would be a cold deck, which where the insulation will be applied to the underside of the ceiling. And again, we're referring back to SR54 where it specifies the 25 millimeter ventilation gap at eave level, 50 millimeter gap in behind the insulation there. And that's where you would install the insulation on the inside of the building underneath the flat roof. And so that's the technical guidance document, Part F, specifying the ventilation of the cold deck. The warm deck is another solution to tackling a flat roof where you would apply the insulation to the upper side, to the outside of the flat roof. That particular scenario, there's no upgrade of ventilation required because the insulation is fitted onto the top side of the roof. Also has its own challenges with a new weatherproof covering as well. But yeah, there's no ventilation requirement once the insulation is done on the top side of the flat roof. The target U value is 0.22 when it comes to U values for flat roofs. So we have other examples when it comes to meeting a whole house solution. And in this example, I suppose prior to commencement of your works, it's probably essential that all the roof elements are surveyed to determine the extent of the works required to achieve your whole surface solution. So for example, that side attic you're looking at there may not have existing access. It might be a smaller attic that never had access at the time of the build. And again, it comes back to your discussions with the homeowner. Highlight these type of things that early on when you're surveying the home. This particular example has quite a large side attic, accounts for up to 37% of all the heat loss roofs. So it is significant, and it wouldn't be grant compliant if that attic was left off. So all heat loss roofs would need to be dealt with. And again, that may need a new hatch, make sure it's treated, and it would then be to standard achieving that whole house solution, because 100% of the heat loss roofs would be treated when the main attic and the side attic would be insulated. We have other situations where you might have smaller extensions, especially, would be common that to be a flat roof extension. Again, This scenario has a habitable heated room as part of the flat roof there. This accounts to up to 16% of all the heat loss roofs in the house. So not only would the main attic will have to be treated to get grant compliance, the rear flat roof extension will have to be treated as part of the grant works to become compliant as well. And so again, you're talking to the homeowner about how that's going to be achieved, etc. We have situations that under the scheme, it might be economically unfeasible to do smaller areas of a heat loss roof. And there would be typically situations where there's restricted access that would potentially require extensive and more expensive work to retrofit. And so the guidance and the standards as part of the grant would be that if this area makes up to, or sorry, less than 15% of the total heat loss roofs, then this is not deemed economically feasible to insulate this area. The uplift isn't as good, the benefits aren't there. It's seen as significant compared to the cost. So to carry out these small works to these challenging areas. So we have this example where we have a small lean-to roof. It only accounts to up to 6% of the total heat loss roofs. And given this is inaccessible, and because it's less than 15% of the total heat loss roofs, then it qualifies to be compliant under the economically feasible rule. So again, the only thing we'd say here is that if you have areas of the home that you're not treating, it's something that it must be clearly outlined as part of the declaration of works. I'm just going to show you how that's done here. So if we look at this table here, but we have a percentage of the total heat loss roof area. So if you're treating 100% of all heat loss roofs, then there's going to be no issues. There's no areas left uninsulated, and it's compliant, or there's no actions or comments needed. It's this scenario here where you're insulating between 85% and 100%. These are the scenarios that you need to put in a comment, and you need to detail, I suppose, the areas that have been left uninsulated and the reasoning behind why. That should be left in the comment box of the declaration of works before you sign off on the works. Again, that's needed in order to be compliant. If you have a situation where you've treated less than 85% of the heat loss roofs within the home, well, that is non-compliant with the grant program. And again, it would advise you to carry out further insulation works to those areas that are left to insulate as part of the thermal envelope and as part of the meeting the whole house solution. So we're going to move on to the next section, which is the pipe insulation standards. And again, this is in the documentation, technical specification, section 6.4.2, and it deals with insulation of water pipes. And it details that all water pipes that are in unheated areas of the roof space, when you're installing attic insulation, must be insulated. All sections must be insulated, including bends, valves, joints. If there's any areas of the pipework or storage tanks that are not sufficiently robust or to withstand the insulation or the water tank insulation, the pipework or the tank should be replaced. So it's something to look out for as well if they're not robust to withstand the new insulation. So we're looking at insulation of all the pipeworks containing water within the attic. Insulation itself must be correctly fitted and secured into position. We look at specific guidance, and this comes from part G of the technical guidance documents, and it's specifically this table 1 in the appendix 1. And so again, it looks at a scenario where you have a diameter of a 20 mil pipe. You might have a situation where you may know the conductivity of the pipe insulation that you're using. But this particular example has a conductivity of 0.035, and then it just specifies the insulation depth there, 23 millimeters of insulation needed on that particular diameter of the pipe. Now, the problem is, in a lot of cases, that the thermal conductivity of the pipe insulation that you're using may not be available, or you may not know it. So generally, as a rule of thumb, wall thickness of the pipe, of the insulation should be greater than the diameter of the pipe. So that's the general rule of thumb here. And so we have a situation where we have an 18 mil pipe with 9 millimeter of insulation, and that would be something that an inspector would pick up on as not be compliant with the grant. So we're looking for the good thick insulation. We have an 18 mil pipe, looking for 22 mil or greater than the diameter of pipe insulation. And so that's something that you need to look out for when you're choosing your pipe insulation. It's definitely something that the inspector will look out for as part of their inspection checklist. So we have examples of this where potentially might be poor workmanship. So again, we have that example of the 9 millimeter pipe insulation there on the left image being used. It's not the right quality of insulation. On the right image here, we have a situation where the insulation is installed, but it's actually not installed on the bends. So we have an example of the joints or the fittings not insulated. So again, there's a risk of freezing here. Upon insulating the attics may be colder after the upgrade. So again, we have that increased risk of pipes freezing. So we're looking towards good workmanship, where you would deal with the bends, deal with the elbows on the joints. So where there'd be an elbow or a T joint, that's exactly what we're looking at here, is the correct methods of dealing with those difficult areas of the pipe. So we're going to choose the correct insulation, make sure it's correctly fitted around the bends and the joints. And if it's taped in position, the inspector will be very happy with the work that's done. So we're going to look at good examples and bad examples. So again, if you have a situation where the pipes are above the insulation level, they will be required to be insulated. So this one here is insulated, but it's poorly fitted pipe insulation. So you can see the area of exposed pipework there. Again, there's a risk of freezing. And where the pipes are running less than 300 millimeters from the ceiling, it would be okay to insulate the pipes below with quilt insulation. So this is an example where the pipes on the right-hand side image are not insulated, or they're not below the quilt. So again, it's something to watch out for as part of your install, and it's something that the inspector would look out for. So what are we looking for? We're looking for joints fully covered and sealed, good quality insulation used throughout, and then the pipes themselves sealed all the way in. There's situations sometimes maybe arising where contractor has not extended the expansion pipe properly into the tank. So in some cases, only the pipe might be extended into the tank and not the pipe itself. So might be other situations where a square is cut out of the tank itself. Both approaches really not acceptable. There's no guarantee that if the water was to boil, that the water will actually enter the tank without spilling out. So they should be terminated below the lid, but not below the water line. So the pipes themselves may need to be extended into the tank. This is exactly what we see in an inspection. You see signs of water making the insulation wet below. You can see specifically that middle image. You have expansion pipe overflowing into the tank, making the insulation wet below, and look, it's visibly overflowing there at inspection stage. We have situations on the left image where the insulation itself is extended in, which isn't the best way to do things. We have a situation where the right image there shows that the pipe just falls short of the tank itself. So we're just encouraging you to extend the pipe in all the way into the tank and not below the water line itself. So we've good examples here. Good workmanship where the feed expansion tanks are fully insulated, fully extended into the tank, terminated below the lids. And that's something that the inspector would look out for. So again, move on to the next item, which would deal with handling electrical works. And the first item would be commonly come across on the inspection would be reset ceiling lights. And again, in order to be compliant under the scheme, if you come across recessed ceiling lights, they should be provided with sufficient space to prevent from overheating. So as part of the specifications, It requires that there's a minimum of 75 millimeters from all ceiling lights. But we do suggest that you use purpose-provided recessed ceiling lighting housing. And again, SR 54 deals with this. It states that voids could be formed around the roof ceiling light itself. If you're forming these voids around this recessed ceiling lights, I suppose the overall effectiveness of the roof insulation will be affected. So again, it might be a situation where you might provide high performance insulation around those voids, compensate for the lack of insulation. It's definitely something that's dealt with well in SR 54. But definitely the recessed ceiling lights do require special consideration. And again, it's part of your initial assessment. You're identifying if there are any of these existing as part of your roof install. Again, you're going to discuss with the homeowner what's needed in order to achieve compliance. Especially in homes where people are investing a lot of money, they may be undertaking air tightness tests in their homes. And when some homes have a lot of these recessed ceiling lights, it's definitely going to affect the overall air tightness of the home. So it's definitely something that needs to be addressed as part of the overall air tightness. Homeowners might be wanting to achieve a certain air tightness result. The more airtight the house, the better it's going to be. And so these need to be dealt with. As part of an inspection, we look at situations where recessed ceiling lights are present. We then look for situations where potentially it might be covered with insulation. We have an example here where the insulation is right up close, tight against the recessed ceiling light. As I said, the insulation should be pulled back at least 75 millimeters from that recessed light. We have a situation where insulation is visible directly behind it. And so, again, these have to be dealt with. So, as part of good workmanship, if you are using purpose-provided downlighters, it would be a good solution to thoroughly clean the area. If you're using these downlight covers, you apply grip adhesive to the entire rim. You're going to push down and seal it. And then if additional adhesive is needed in order to perform that, to get that good air tightness seal, that would be a good solution. Once it's fully protected with a certified downlight cover, it would then be covered or being able to cover safe from a risk of overheating. Again, if you're dealing with lights, downlight covers that have LED lights, less likely to overheat, but again, they have to be treated the same as halogen lamps and they still need to be protected. Other situations when handling electrical work would deal with high power cables. And so again, the 6 square or large or heavy duty electrical cables that's shown here should not be covered by insulation. So we have examples of maybe appliances such as electric showers, electric stoves, cooker tops, like induction hobs. We have these type of appliances in the home that have 6 square or higher electrical cables. So these shouldn't be covered. There's a risk of overheat, could result in fire. So it's good practice to pull these cables up over the insulation, if at all possible. Now I know some cases the cables might run through the joists. And if that is the case, it would be required just to pull the insulation back from the electrical cables themselves. So as I said, generally cooker cables, electric shower cables, and it's something that when you're doing your install, just be alert to the presence of those appliances. The cables themselves will be running up through the attic across to the fuse board. So it would be that span of distance that you would need to make sure that the cables are lifted. It's something that an inspector will exactly look out for. In the past, before entering roof spaces, I would also just check maybe is there an electric shower, the location of it before I entered the attic, just to see if I can identify where the cables are. As an inspection, we would do just the same, identify where the potential cables are going to be. And again, we'd be expecting to see them lifted up above the insulation, or if it's not possible, the insulation itself pulled back. So again, part of your initial survey, you're going to be checking as part of your installation, is this type of heavy duties there. These appliances require heavy duty cables. They may be incorrectly installed. So again, it just makes them more dangerous if they're not lifted above the insulation. You have situations just being picked up during inspection that would require rework. We have these heavy duty cables just covered by insulation. Now, the thing is, it could be covered by some homeowners' existing insulation, so they may not have been visible from the start. So again, this is something to pay extra attention to. It may be underneath existing insulation, so you still need to look out for them to be lifted. Um, so yeah, the inspector would look for these cables to be lifted. This is a good situation where inspectors identify the cables. They're clearly visible. They're running from the appliance in the attic over to where the fuse board would be below. And so they're all lifted, and it's something that the inspector would, once to see that, it goes up. That's it. There actually has been special attention made to lift those cables. So it's been good workmanship in that particular example. So we'll move on, and we're looking at insulation of water storage tanks. So again, insulating the roof at ceiling level, it's going to mean that the temperature within the roof will be close to the external temperature. So that makes it more important to insulate the water tanks to prevent from freezing. This particular image is from SR54, and it's a good one because it shows where the water tanks themselves are down close to the ceiling level. And the insulation is to be left clear underneath. And so that would prevent the heat from below, prevents freezing. That would prevent from the cold water storage tank from freezing. In that particular case, the insulation is fully covering the outside of the tank and turned up at the bottom, but the bottom side is left clear because the tank itself is close to the ceiling level. So that's something to look at. How far is the tank from the actual ceiling level? When it comes to raised tanks, they should be insulated as normal. So the underside of the tank would be required to be insulated if the tank is raised, say above the quilt level, above 300 millimeters of the quilt level. So we have the insulation on this particular example. The tank is insulated and the lid. There's no insulation fitted to the underside. That could prevent freezing. And we have a situation over here on the right image where the quilt itself is skirted up around the side of the tank. So again, that's a situation where you have the heat coming from below, preventing the tank from freezing. The insulation is quilted up or skirted up around the tank. With examples here where the tank, potentially a feed and expansion tank, is greater than 300 millimeters above the finished insulation level, but the tank itself has insulation installed to the underside of the tank. So again, that's a good job. Special attention has been made to insulate those tanks, and it's something that an inspector will look out for where a situation where you have raised water tanks. These situations where the insulation may have been provided, but not correctly held in place. So again, that's required in situations where we have water tanks not being insulated. And again, it's going to be a bigger risk of those water tanks and those pipes freezing, especially when the insulation is treated or installed at ceiling level. The temperature is going to be a lot colder when that kind of work is done. So they have to be treated in order to get compliance with the grants, prevent any reworks. Good examples of this would be where we see the tanks are fully insulated throughout, correctly taped, correctly fitted with lids. And so again, when it comes to insulation of the lids, insulation or the lid itself would need to be removed from time to time for maintenance. So again, it's something to just bear in mind when you're installing your insulation of the water tanks. It will potentially need the lid removed, so just bear that in mind as well. We have a good example here where the contractor has actually provided good supports for the lids. So again, if those weren't provided, it may be a situation where the tank insulation, the lid insulation is not correctly supported. It may actually prevent another call out to fix an issue. So having the correct supports in place for the lids and for the water lid insulation will be a good example of a good workmanship. So we're coming towards the end of the presentation. I just want to point you towards the support for contractors page. Look, a lot of the things we covered there during the presentation is available on the support for contractors page on the SEAI website. So again, I would just make yourself and your team available familiar with what's there. The support, all the documents we went through are available to download. And there is actually some good technical bulletins that have been issued over the last number of months and last number of years that deal with specifically roof insulation. So again, we've dealt with some of the items there, but again, just additional items that would be of use to you as part of the support for contractors. And as part of the contractor training series over the last number of years, there has been a lot of contractor training videos, recordings of similar sessions where we would deal with, other measures like heat pumps and heating controls, that kind of thing. So again, if it's something that interests you, it is all available on the supports for contractors page on the SEAI website. So again, that brings me to the end of my session. Again, if you have any questions, feel free to pop them in the Q&A section there. And Roland, I might just hand back to you now if you want to start.
Yeah.
Taking some of the questions.
That's great, Michael. Thanks a million. That was brilliant. I'm just going to stop the recording now and